So this is the code walkthrough for deep I2I architecture. So the code is firstly borrowed from Big GAN architecture, and they have taken the pipeline so that this can be used for their task. So there are several files. So our main concern is train function. So in the train function, they have a set of arguments which specifies which learning rate to use, how much learning rate to use, how much alpha constant should be there, and etc. for the generator, adapter, discriminator, and encoder network. So here is the main file which trains the architecture. So what it does is it takes the particular dataset according to the argument, and it will call the dataset, and it will train the dataset according to the batch size and other stuffs that are given. So here is the main function, and it calls a lot of stuffs. So this function in turn calls another function, that is train functions. So train function calls this function which have which is designed particularly for the training of GANs. So here it is doing training. So firstly they are just taking the x and y's from the dataset. X means the image and y means the class level, and target x and target y are the images which the GAN is supposed to generate. And here it calls the discriminator number of steps, and it samples here. It generates a fake and real image, and it calculates the loss here, and it does a backward pass. So similarly this is for the discriminator, and similarly this is doing the same thing for the generator here. So what it is doing is actually it is computing the loss for generator. So firstly it is training the discriminator, then this is training the generator, and this continues to train for a certain number of epochs or till the number of batches is completed for the dataset. The main thing is the losses. So this is the DC GAN loss, which is doing just a soft plus of minus of dis real, the features that is getting into it, and this is doing a just dis fake, the feature of which it is getting. So this is the loss for DC GAN discriminator, and similarly for the loss for DC GAN generator, they are taking a whole lot of alpha values, and they are combining the activations from different layers of the adapter, and they are computing a reconstruction loss, and they are sending the loss. So this is the original loss, that is the hinge loss, and this is the DC GAN loss which I have coded, and similarly this is the SISDL loss which we haven't tried out yet, and this is the SSIM loss, structural similarity index. And here we are generating the loss for the discriminator through SSIM, and here we are generating the loss for the generator through SSIM, and here we are just including it. So these are the main loss function, and this is the layer of the GAN network. This is a utility function code which gets called in the Big GAN this architecture. So this is the main architecture, Big GAN architecture, and here is the generator. So if we read the paper, we will be able to classify what the generator is actually doing. Similarly, this is the generator code, then this is the discriminator code. So they are taking a set of activations from different layers, and they are assembling it for further generation of new sample images. So this is the encoder architecture's code. So there are a lot of code, and to be honest, in 5 minutes we can't cover this, so I am just covering the essential part. Then this is the alignment block. So alignment block means the adapter network. So in adapter network, they are just taking different activations and resolution, and they're fusing it, for which the generator and the discriminator is trained in a good way, and there is semantic consistencies between the different layers for generating the images. So this is the generator code, and so main architecture means main hyperparameter tuning is in the script. So like when we are training it, so here we are passing several kind of arguments, like do we need to have HDF5 format, since most of the data is converted to HDF5 before processing for faster batch processing. Then there is different kind of hyperparameters like the generator, the learning rate, discriminator, and the other stuffs. And there is the ortho and other kind of fine-tune stuffs which the generator and the discriminator needs for better training. And we are passing the experiment name, so this is for food dataset, and we are saving and testing every this much iterations. So these are the iterations. So this is how the training is done, and here we are we should run this code for testing. So we can run different codes for testing the stuffs that we want to do. So this is the kind of code review overview. So let's move on to the demo.